So, who am I? Well, that's a pretty complex topic. I'd rather choose to talk about something a little more simpler. But my name is Doug May, and I run a practice here at Splunk called Global Specialization. And we help customers document value they get from Splunk and what they can expect, and help prescribe the right data sources and use cases for them to get that value. But the big question you probably ask when you hear about Splunk is, what is machine data? This thing that Splunk talks about all the time, about data that they make accessible, usable, and valuable to everyone. So what is it? Well, number one, it's super fast growing. How many times have you looked at your cell phone today? If you've done it as many as I have, you've probably generated tons and tons of data in the mobile device, and the network, and the applications, and the servers, and the databases that are powering all the apps that you have. The other part of this is not only is it fast growing because it's being generated all the time, but frankly, it's really, really complex. And that complexity means it's really hard to use to gain advantage in your business. And one of the big problems is that it lacks structure. There is literally nothing that is structured about a log file. It's a bunch of characters, numbers, letters, special signs, and all separated by commas. And it's really tough for you to be able to leverage that. So Splunk, that's what we do. Typically, this data resides in a few different areas of your organization. The first is the infrastructure. This is the people who are responsible for server, storage, and network, the compute aspect of the organization. There's machine data that resides in your applications teams, which is made up of database and middleware, and of course the application code. There's your security team as well. But there's also data out there that is becoming increasingly more popular, which is the IoT, or Internet of Things data. This is data that's residing in sensors. We actually have a Splunker who taps maple trees to get maple syrup. And that maple tree produces, he's got 1,200 trees generating all this data of the syrup coming out, and then when it goes in to get cooked, he's got sensors linked up to the whole cooking process, can do some really interesting analytics. And we've got customers, of course, doing things on a commercial basis that are really popular there. So let's go back and focus in on the infrastructure. And here I was talking about the network team, your server team, and of course the storage team. So these are three different layers that typically makes up infrastructure in any organization. And it's all really about the compute. The interesting part of this, of course, is that these are all separate technology layers. But in also the separate technology layers, there typically are separate teams, people who are experts. And of course, they're working all day long to try to make sure that their customer is happy. Everybody wants a happy customer. So what they do is they try to monitor these systems and make sure they're up and running all the time, and when something breaks, they try to fix it. The interesting thing is over on the application side, so if I'm a user, I use an application, whether that's an online banking application or an internal application that helps me do my job, or a mobile app that I might buy something online with. The reality is those are made up of databases, maybe a middleware tier, and of course some application code. And again, separate teams with separate people. Now, inevitably, in all of this, something goes wrong. And there might be a little fire that starts burning. Get a little heat going up off the fire. Last fire I drew looked like a turkey, so hopefully you think this one looks a little better. But when that fire occurs, what happens in this environment? The storage team starts looking at their data, and the database administrators start logging into database logs, and app developers look at their stuff, and the network logs in and takes a look at their stuff. And inevitably, what happens? It's this. I'm pointing and I'm pointing and I'm pointing. Database person says the network is clearly not performing because my query's taking too long to finish, or they failed. The network team is saying, well, the application team, they don't know how to write code. It's too complex and it bogs down the network. So there's a lot of finger pointing, which means a lot of problems last a long time. Everyone's been in the war room, right? Who hasn't been in the war room? Well, I've been in the war room, and it's not fun. It's not pretty. It lasts a long time. It takes every one of these teams looking at their stuff and pointing fingers at others. Eventually, someone finds the problem. There's a hero, and they're given a gold star. Or maybe, in this case, a green star for solving the problem. But the idea is with Splunk, what if we could make this data a lot easier to access. And if we put it all in one place with Splunk, we can actually allow these wonderfully powerful and expert resources to leverage the data and to correlate that data with other data sources. Imagine if you could see what the database query did to the network at the very same time. What if you could then see how the network's performance was affecting the app team? Or how the middleware tier was writing, efficiently or not, to the storage layer? It becomes wildly powerful. In fact, if you want some stats, we've got them. Fighting the fires with Splunk, we can save you 70 to 90% of the time. It's just significantly faster to leverage Splunk, have everybody looking at one screen, doing searches to correlate and find the issue, and, frankly, put out the fire. Okay. The other thing that customers get from that is because they can start monitoring with Splunk and leveraging different data sources and searches and queries to create alerts and also find root cause after the incident, customers get a 15 to 45% reduction in the frequency of their critical incidents. Think about that. Who here wouldn't like to have 15 to 45% fewer war room calls? It really frees up your time to go out and do something pretty productive like golf or knitting, or what I started recently, horseback riding. So think about it. You too could be riding a horse right now instead of working on an IT outage. Okay, well, there's more data in the organization too, more machine data, this highly structured, unstructured, complex, fast-growing data, and it's in security. Think of all the cyber threats that are out there and all the different data available to security professionals to make good decisions about investigating and solving issues. We've got Active Directory or traditional LDAP data. We've got your proxy server data. We've got firewall data. What else do we have? IDS, IPS, CPA, MBA. There's a whole bunch of letters I could put out here and sound really smart. Only the real security people will know what I'm doing. So hopefully you get this. Maybe even antivirus, another type of data source that could be helpful for you to look at. And again, just like the IT and the application side, it's all separate. Separate tools, separate log files, separate data sources. And of course, we got more people, more experts in what they do, but they don't have access to all this other data. So in security, what ends up happening, if I have an alert from any one of these systems, I have to manually go find if the alert is in fact a real threat, whether there's really a bad guy in my organization or whether I've lost something critical. So with Splunk, imagine, if you will, the ability to put all this data into one place and have the collective power of your security professionals be looking at one screen to solve the problem. Well, what happens in that scenario? Guess what? That 70 to 90% reduction in time that customers who use Splunk and IT operations get, the security people do too. It's available for everybody. Value for everybody, speed, time, all of that. The other thing that they get from it is a reduction in risk. I don't know about you, but nobody wants to be wearing the orange jumpsuit. It's not a very happy scene. So the orange jumpsuit, we want to avoid it. So what do we do in that case when we help customers do this? Again, reduce their risk of data breach, of IP theft, of fraud taking place in the organization. So really, really interesting. But now, we've looked at IT operations and applications and security, but isn't it pretty interesting to think about this? What if the operations team who's managing the incidents here could leverage the Active Directory or LDAP data? Well, if they're having problems with a user accessing an application, it would be really helpful if they had the system of record that authenticates those users and they could validate whether or not something had gone wrong in that system. Likewise, if I was the security team and I had an alert from one of my systems that said someone bad might be doing something, I might want to leverage this data to help solve that problem. But I might also want to know What did they do in the application? What functions and features and transactions did they make happen? Because I want to know, did someone steal my money? I hope not. So what you see is the ability to leverage data in one place can make your teams far more efficient, saving time, avoiding impact in the business, also leveraging the data in security to reduce your risk. And the magic happens, the super duper magic happens, and we get to the nirvana of dollars everywhere when you can, in fact, leverage the data sources across one another. The way you buy Splunk, you pay for the data when it goes in. You can use it as many times as you want, by as many groups as you want. So, if you can still see me, I would like to suggest that you check out our latest ebook titled The Essential Guide to Machine Data. It's going to help you determine which data sources you can leverage across the organization to get even more value out of Splunk. Thanks, and appreciate you playing with me during this experiment.